Hello guys, this is CodeNCode and this is video editorial for the problem 0 reminder array taken from Codeforces div 3 round 653. So the problem is we are given an array of n integers and positive integers, and initially we have an integer x which is 0. Now there are two different operations you can perform. First, you can either choose any index I and add x to it. When you add x to it, x of course it would be incremented by x and x would increment by 1. Otherwise what you can do, you can just increment x. So in first operation there are two things happening. First, you can add x, the current value of x, into certain element, only one element in one operation, and after that the value of x will increment. Otherwise you can just choose to increment x. So these are two different operations. Either way the value of x is going to be increment in every operation, because in the first, in the second, in both of the operations the value of x is actually being incremented by exactly 1. So we have to find the minimum number of operations that is required to make all of the integers given in the input to be divisible by some integer k. K will be given in the input. So we are given an array of n positive integers, and we are allowed to perform these two operations, and we have to find the minimum number of operations that we need to perform to make all of the integers in the input divisible by k. So this is the problem. So I want you to just pause the video, or you can just go and read the problem statement yourself. Just pause the video and try understanding this. So this is an example of first test case. The answer is 6, because we need 6 operation to make all of the integers divisible by 3. So this is n, this is k, there are 4 integers and k is equals to 3. So finally 1 2 1 3, you have to update this in a way such that the resultant array must be divisible by 3, all of the elements in the resultant array, and this is the final array. You can see each step they have explained in detail, so I'm just ignoring this. Just pause the video and read it. Now the question rises how we are going to solve this. First, let me take you to through an example, and this is an example 2 and 5, which means there are two integers and k is equals to 5. So we have given two integers 3 and 8, and we have to find the minimum number of operations to make these two divisible by 5. So first, an important observation which is very basic and naive as well. So first, x starts with 0, and after every operation as x increases by exactly 1. So this is very naive observation, nothing special here. So you see, at x is equals to 7 both will be divisible by 5. How so? See, when x is equals to 0 initially, you can add it either to first and second and nothing happens because none of the element will be divisible by 5 till now. Now what you can do, of course we will increment x, and x is now 1. Even after adding 1, none of the element will be divisible by 5. So what we'll do, we'll go to 2. Now x is 2 now, and you can add x to either 3 or 5. Suppose I added it to 3, so now it would become 5, and 5 is divisible by 5. So at least we have taken care of one element in 3 operations. Why 3 operations? First operation was to increment x by 1, so it became 1. So it became 1. Now another operation, the second operation, was to increment x by 1 again, so that it can become 2. So in 2 operations we have came from 0 to 2. Now in third operation you will add it to this. So when x is equals to 2, actually we have performed 3 operations. So now x is equals to 2, we have added into 3, and now x has incremented as well. So x is now 3. Now 3 won't help this, 4 won't help this, 5 6 nothing would make it divisible by 5. When x is equals to 7, you can add it into 8, it would become 15. And now when x is equals to 7, actually 3 and 8 both will be divisible by 5, because at x is equals to 2 we have added 2 into 3, so it has become 5. Now at x is equals to 7, I have added 7 to 8, so it has become 15. So finally at x is equals to 7 we will have 5 and 15, and both are divisible by 5. So the minimum number of operation, since at x is equals to 7 we are able to make the whole array divisible by k, so the total number of operation will be x plus 1, because we need to go from 0 to 1 as well, because that is an extra step. That's why the total number of operations will be x plus 1. So you have to find minimum x up to which all of the elements are divisible by k, and then the result will be x plus 1. If x is already 0, that means if all of the elements are already divisible by k, in that case we are going to print 0. Otherwise we'll find minimum x such that up to which all of the elements will become divisible by k, and then we'll print x plus 1, because in this case it would take 8 number of operations. So the second observation is important. You see, 3 and 8 both lie in the same group. These two integers, they both lie in the same group, and I'm forming the group by modulo. So if any integer, two integers are leaving the same remainder when divided by k, then they are in the same group. So 3 leaves remainder 3 when divided by 5, and 8 leaves remainder 3 when divided by 5. So both of them are leaving the same remainder. That is why they both are in the same group. So 3 and 8 are in the same group. Now why I am grouping all of the elements using modular arithmetic or remainder, I'll be showing you in a minute, and that is very important. And let me show you why do that. So suppose we have input, this is the last special case I'm taking. After that I'll be generalizing my algorithm. Now we have input 3 and 5, which means there are 3 integers and we have to make all of them divisible by 5. Now the input is 4, 4, 4. As you can see, all of them are leaving remainder 4 when divided by 5. So of course all these 3 lie in the same group. So I've created a map MP which will store how many elements are there with remainder certain x. So in the given input there are 3 integers which are leaving remainder 4. So key would be the remainder, and of course the value would be the number of integers leaving that much remainder. Now map is actually key value pair data structure, so you might know about it. So now there are 3 integers in the same group. So what is the minimum number of minimum k x, I guess minimum x we can achieve? Now see, in the first integer I'm adding 1, right? If we add 1 to it, it would become 5, and 5 is divisible by 5, of course. Now in the second element I am adding the 6. Why? Because 6 is the minimum x after 1. After adding this to any element in the input array, it would become divisible by 5. You can try it. You can try adding 2 in the second element. You can try adding 3, 4, 5. Nothing would happen. Only 6 is the minimum element. After adding this to the next element, it would become divisible by 5. So I would add 6 to it. It would become of course 10. Now x3 I would be adding 11. Why 11? Again, this is the minimum x after 6 which can make a number which is 4 divisible by 5. Now why I'm talking specifically on these number is because this observation. If you see, all of these are in the same group because of modulo, because they are leaving same remainder. Now just observe these 3 integers, 1, 6 and 11. What do you see? If you observe this using modular arithmetic, you see 1, 6 and 11 all are leaving same remainder when divided by 5. 1 modulo 5 is 1, 6 modulo 5 is 1, 11 modulo 5 is 1. All of them are leaving same remainder. Now is it is it only by chance that all these 3 integers are leaving the same remainder when divided by k, or there is a connection between them? Well, the connection, as I have already shown here, is this. The claim is sum of 2 integers is divisible by k if and only if sum of their remainder is divisible by k. Now read it again. Sum of 2 integers is divisible by k if and only if the sum of their remainder is divisible by k. Now see here, all of these integers are leaving remainder 4. All of these integers leaving remainder 5. If you add 4 and 1, it will become 5, and 5 is divisible by 5, right? So remainder of these integers and remainder of these integers, if you add them, if you take any integer from here, take remainder of that and take remainder of that, you would add them together and you see that sum of them is divisible by 5, which is k, and that is what it says. Now this claim, can we prove it? Yes, we can prove it, and I'm leaving this as an exercise to you. You can prove. Hint would be to use Euclid division algorithm. You can use Euclid division algorithm and prove this fact. So now we know that what we want. So for any integer ai, if it is leaving reminders such if it is leaving reminder say x, then what we need k minus x to be we need an element which leaves reminder k minus x to add into this, so that sum of their reminder can become divisible by k. That is why I'm grouping all of the integers. Now you might know why I'm grouping all of the integers based on the reminder that they are leaving. That is why all of these elements are in the same group, because all of these integers want that number to be added into them which is leaving reminder 1. Why? Because these are leaving reminder 4. If you add any integer which leaves reminder 1, sum of their reminder would be 5, which will be divisible by k, of course. That is why all of these integers are leaving reminder 1, and that is why after adding these element into any of this element will result into an integer which is divisible by k. So now you see, for this the result will be 12, because minimum x is 11. So you can also add, instead of 11 in the third element, you can also add 16, which will again leave reminder 1 when divided by 5. 16 also leaves reminder 1. 21 also leaves reminder 1 when divided by 5. So you can add 16, 21, 36 and so on, any number which leaves reminder 1 when divided by 5. But since we want the minimum number of operations, so we would want to know the minimum x. So out of all of these, the maximum x is 11. That means you need at least x to be 11, right? So the minimum x, so minimum number of operation here would be 12, because minimum x at least we need up to 11. I can add 1 into one element, 6 into another element, and 11 into another element. So at least I want x to go as large as 11. So the number of operation would be 11 plus 1, that is 12. So now that you know that two numbers are divisible if they're if sum of two numbers is divisible by k, if sum of their remainder is divisible by k. So, and you know that thing, and also you know why I'm grouping the integers based on their remainder. Now I can explain you how the problem is solved. So I'm taking the example from the example test case. In the given problem, this is the example. I've created the map. So there are 3 integers which are leaving remainder 1, 2 integers which are 3 integers which are leaving remainder 2, 2 integers which are leaving remainder 3, 1 integer which leaves remainder 4, and 1 integer which leaves remainder 5 when divided by 6, because k is 6 here. Now to satisfy all of the integers which are leaving 1 remainder when divided by 6, we need these. In the first element I can add 5, because this is the first element which leaves remainder 5, because in the element which leave remainder 1 we need integer which leave remainder 5, right? So that their sum is divisible by 6. So if an integer leaving remainder x, then you need to, in that integer you need to add an integer which leaves remainder k minus x, and this is k minus x, the first integer. So in the first element which leaves remainder 1 is, I guess, 7 here. In 7 you can add 5, in 1 you can add 11, in another 7 you can add 17. So basically we will start from that integer itself. So we need 5, so first integer would be 5 which leaves remainder 5 when divided by 6. The other integer would be just add 6 to it, which is k. 5 plus 6 11, 11 plus 6 17. So 17. To satisfy all of the needs of elements which leave remainder 2, we need element 4, 10 and 16. To satisfy need of these we need 3 and 9. To satisfy need of this we need 2 and 1. What is the maximum out of all of these? 17. So you need to go till 17 at least, and since we want to find the minimum x, so 17 would be the minimum. So in this operation the result is going to be 18, because we need to go up to 17, and since we are going till 17, so the number of operation will be 18, because of x, we start x from 0. So all you have to do is group integers based on their remainder that they leave, and depending upon the number of integer in any group, find the maximum element, and find from each group find the maxima of every single group. I mean among all of these groups. So the maxima comes out to be x. Result would be x plus 1 if x is not 0. So this is what I'm doing here. I've created a map of integers so that I can store this information, how many integers are the count of integer leaving certain remainder. This is n and k. In each test case I'm reading n and k, and of course since there are more than one test cases, so in each test case I need to clear the map. After that, running a loop from 1 to n, each time reading x, the integer in the input, and then incrementing at position ar of x modulo k. So this way basically I am counting the number of integer leaving certain remainder. Now after that, initializing the maximum to be 0. Since this is map, so it stores the value in key value pair. So I'm using enhanced for loop. So each time I'm taking every single pair, I'm reading the map pair by pair. So first it would give me 1 3, 1 is the key, 3 is the value. Then it would give me 2 3, 3 2, 4 1 and 5 1. I am assuming you are aware with for it is also known as, I guess, for each loop or the enhanced for loop. So basically I'm traversing each pair one by one from the map. P dot first will tell you the total number of element, and P dot first, this is pair from each, this is pair, and then of course it has two values, first and second. First value you can access by P dot first, ff is actually first, ss is second. So to access first value you can do P dot first, P dot ff will give you this, the key, and P dot second, P dot ss will give you count. So this is the count and this is the key. If key is not equal to 0, yeah, if the element is already 0, if the element is already divisible by k, then only of course key would be 0, right? So if key is already 0, you don't have to do anything because those numbers are already divisible by k. So if I is not equals to 0, that means I'm finding the max element. This is the formula. How I got to this formula, I want you to find out yourself. This is as an exercise. It is not like I cannot explain it. I leave most of the thing to yourself so that you can learn as much as you can. The reason is, the more you invest yourself into doing something, the more you will remember it for longer. So that's why I leave most of the thing for you guys to do. So find out how this formula will give you the maximum element of the group with key I. After that, finding all of the maximum. If mx is positive, that means we are performing certain operation, which means all of the elements are not divisible already. So we are incrementing it by 1 because of course if the maximum comes out to be x, then the result is x plus 1. If it is already 0, then this if condition will not be true and the result will be 0. So this is how I solve this problem, and this is how you can solve this problem. I'll be putting the link of this solution into the description of the video. If you have any doubt or query, of course you can ask me in the comment section. Thank you guys for watching. Until the next video drops, keep coding. Thank you.